All right, so we discovered the source of the error in our contract. I've now taken the liberty to create another version of our contract. I'm calling it Step 2, in which we will fix the error that we discovered. So the error was that since we're dealing with unsigned 64-bit integers, if we try to decrement our counter value below 0, it will try to create a negative number, and teal doesn't allow for negative numbers, and so it fails. In order to fix this issue, what we are going to do is detect if subtracting 1 from the current value of the global counter will cause it to fall below 0, and if that is the case, we are not going to do anything. So it will just silently not do anything. And we can do that by loading in the value of our global counter into what's called a scratch variable, which acts just like a temporary variable. When the transaction is over, it is forgotten, and then use that scratch variable to compare against our condition and figure out whether or not we should actually perform the decrement operation. So how do we create a scratch variable? Well, we declare it up here next to all the rest of our identifiers, and I'm going to call it scratch counter, and we'll set that equal to scratch var, and inside of here we can put the type, which is teal type.uint64. All right, now inside of our decrement operation, we're going to say scratch counter.store. And what are we going to store? Well, we're going to store the value of our global counter. And then we want to perform a comparison operation, so we can use the if statement. And we'll say if scratch counter.load is greater than int 0, then we can perform the put operation. And here we will say scratch counter.load again to reuse that value. And that is pretty much all we need to do to solve the decrement issue. Now, some of you may be familiar, this is called an underflow. So we're saying we're going to detect underflow here. And actually, it is entirely possible for overflow to occur as well. That's where the value of our counter grows so large that the data type of unsigned 64-bit integer can no longer contain it. Now, that is exceedingly unlikely, given that we are only allowing increments of 1 at a time. But in the spirit of good practice, we are going to work on that as well. So we're going to detect overflow as well. And what's the value that we need to be looking at? Well, I'm going to define a constant up here. We'll call it uint64 max, and that's going to be equal to, if we write it in hexadecimal, well, we're dealing with 64 bits, which is 8 bytes, and each byte is 2 characters in hexadecimal. So it'll look something like this. That's 16 Fs, which means that is all of the ones are turned on, and that is the largest integer value that can be stored in a 64-bit unsigned integer. All right, so we'll just come over here to our increment method and make sure that our value is less than uint64 max, and change this to a plus sign. Delete that line, we don't need that. Just double check here, everything looks good, and that should solve our problem. So let's build our contract again. We'll say build.sh contracts.counter step 02. Build that. Wonderful. And now let's deploy it. So let's see. I want to say goal list account list. Make sure that I have my environment variable here set 1 there, and then I have my deploy command right here so that I don't have to type it all out again. We'll just copy that, paste it in there, deploy our new version of this contract, and then we'll say goal app call app ID 1, and then we're going to say from 1 app arg str dec, and see if that works. It should just do nothing. So then if we say, if we read the story, say goal app read app ID 1 and global guess format, then counter should still be 0. And that looks fabulous there. So we have solved the bug in our counter program.